Welcome to How to Automate Data Pipelines with Airflow and Python. In this video, we'll dive into setting up, scheduling, and monitoring a basic data pipeline using Apache Airflow and Python. By the end, you'll gain essential skills in automation, enhancing efficiency and reliability in your data engineering tasks.
Let's kick off by discussing Apache Airflow, a powerful platform to programmatically author, schedule, and monitor workflows. Airflow is a critical tool in the realm of data engineering, offering the ability to automate complex data pipelines. This open-source solution stands out because it allows for a highly granular control of workflow execution, making it a favorite among data engineers. From ETL processes to machine learning pipelines, the use cases of Airflow are vast. It not only boosts efficiency but also ensures reliability and transparency in your data workflows. By understanding and leveraging Airflow, you can transform your data processes into streamlined, automated operations.
Now that we understand the power of Airflow, let's get into setting up your environment. First, ensure you have Python installed, as it is crucial for running Airflow. We'll begin by installing Apache Airflow using pip, the Python package manager. You can do this by running pip install Apache Airflow. Next, configure your Python environment to manage dependencies efficiently. Understanding the basic architecture of Airflow is important. It consists of components like the scheduler, web server, and workers. Setting up these components correctly is vital for the smooth functioning of your workflows. Once installed, initiate your Airflow database with AirflowDB in it. This sets you on the path to creating your first data pipeline.
With Airflow installed, we move on to creating a directed acyclic graph, or DAG. A DAG is a core concept in Airflow, representing a collection of tasks in a workflow organized in a way that reflects their dependencies. In simple terms, it's a blueprint of the steps your data pipeline will take. Let's create your first DAG. Begin by defining the DAG in a Python file, specifying parameters like the start date and schedule interval. Within this DAG, you'll define tasks, which form the building blocks of your data pipeline. The structure of a DAG is crucial because it dictates how tasks are executed and managed. By understanding and designing effective DAGs, you ensure that your workflows run seamlessly. In any workflow, tasks are rarely independent. They depend on each other, forming a sequence in which they must be executed. Airflow's power is in its ability to define these dependencies clearly. When configuring your DAG, you'll specify which tasks need to run before others using the set_upstream and set_downstream methods. Scheduling is another critical aspect. Airflow uses a scheduler to manage task execution timing, allowing tasks to run at specified intervals. This flexibility ensures that your data pipelines run as needed without manual intervention. Understanding task dependencies and scheduling effectively can significantly enhance the performance and reliability of your workflows. Airflow tasks are typically defined using Python. This integration allows you to leverage Python's power and flexibility in your workflows. Airflow comes with several operators, like the Python operator, which lets you execute Python functions as tasks within a DAG. This is particularly useful if you have existing Python scripts that perform data processing, analysis, or transformation. By integrating these scripts into Airflow, you ensure they run in a managed, scheduled environment, enhancing reliability and consistency. Let's walk through an example. We'll take a simple Python function and integrate it into an Airflow task, illustrating how to seamlessly blend Python scripting with Airflow's orchestration capabilities.
Once your pipeline is up and running, monitoring its performance is crucial. Airflow provides a robust web interface that gives you a real-time view of your DAGs and tasks. Here, you can check task statuses, view logs, and identify any errors that may occur. Logs are particularly important. They provide detailed insights into what happened during task execution. If something goes wrong, the logs are your first port of call for troubleshooting. Proactive monitoring allows you to catch issues early, minimizing disruptions. By leveraging Airflow's monitoring tools, you ensure your data pipelines run smoothly and efficiently. No system is infallible, and errors are a natural part of any data pipeline. Airflow offers robust mechanisms for handling these errors gracefully. By configuring task retries, you ensure failed tasks are automatically retried, reducing manual intervention. You can specify the number of retries and the delay between attempts, tailoring it to your workflow's needs. Error handling strategies, such as defining fallback tasks or notifications, further enhance resilience. These practices not only minimize downtime but also ensure that your data pipelines can recover from failures without significant disruption, maintaining the integrity and reliability of your data processes. As your data grows, so do the demands on your data pipelines. Scalability becomes a key consideration. Airflow supports parallelism, allowing multiple tasks to run concurrently, maximizing resource utilization. Understanding how to configure this is crucial for handling larger data sets efficiently. By optimizing task execution and managing resources effectively, you ensure that your pipelines can scale with your data needs. Scalable pipelines not only enhance performance but also future-proof your data infrastructure, allowing you to handle increasing data volumes without compromising on efficiency or reliability.
We've journeyed through the essentials of automating data pipelines using Apache Airflow and Python. From setting up your environment to monitoring and scaling your workflows, you're now equipped with the knowledge to enhance your data engineering processes. Automation not only boosts efficiency but also ensures reliability and scalability, key in today's data-driven world. We encourage you to experiment with Airflow, adapting it to your unique needs. If you found this video helpful, please like, share, and comment below with any questions or topics you'd like us to cover in the future. Your feedback is invaluable in shaping our content and ensuring we provide the most relevant and engaging information.